This is Problem Solved, the IISE podcast, where we talk to industrial and systems engineers about their work, ideas, and solutions.
Hello, and welcome to Problem Solved, the IISE podcast. I'm Keith Albertson, managing editor of IISE Magazine. On November 3rd, voters across the United States will head to the polls for the 2020 presidential election. During early voting, many areas of the country have experienced long lines, lengthy waits, and other challenges due to heavy turnout and social distancing requirements amid the COVID-19 pandemic. In this episode, we talked to two industrial and systems engineering professors and IISE members about their research aimed at streamlining procedures for in-person voting. Our guest on Problem Solved now is Laura Albert. She's a professor of industrial and systems engineering and a Harvey D. Spangler faculty scholar at the University of Wisconsin-Madison. Her areas of research have involved creating operations research models for emergency response, homeland security, and infrastructure protection. She's also a newly selected IISE Fellow to be honored at the virtual annual conference. She recently has authored a paper with Adam Schmidt on creating resilient voting systems during the COVID-19 pandemic. It was featured on her blog, Punk Rock Operations Research. Today, we're going to talk a little bit about voting systems. We're not going to discuss politics, which everyone has heard plenty of, but we're going to talk about processes. Professor Albert, welcome.
Thank you. And I'm glad we're sticking to the numbers because I'm much more comfortable crunching numbers than talking politics.
I'm sure everyone is more comfortable with that. Tell us a little bit first just about your background in industrial engineering and why you headed into some of the specialties that you have.
Yeah, so I have been a long time industrial engineer. My undergraduate degree is in general engineering at Illinois, which is now a systems engineering department. And I headed straight through to get a PhD. I always knew I was kind of drawn to research and got involved in some dissertation research involving aviation security and decided to continue as a professor of industrial engineering. And all of my research is really focused on public sector problems and how to reduce and manage risk in interesting and important public sector problems.
Well, tell us how you got involved in the research involving election processes. When did that begin and how did that become an interest that you wanted to pursue?
Well, it just started with a conversation this summer. I mean, I barely left the house this summer, but I happened to run into Barry Burden, who's a professor of political science here at UW-Madison with me. And he started talking about the importance of queuing theory and location analysis in elections. And it just caught my attention. I know about those and I'm very interested in those. And that led to some follow-up virtual conversations. And we're very much interested in how to design like a new type of election for in-person voting for the fall election. The pandemic introduces some challenges, but it also opens the door for election officials to try some new things that they haven't before. And the literature really hadn't gotten into that. A lot of the literature really focuses on how to allocate voting machines. And I was just really intrigued by what industrial engineering tools could offer for preparing for the fall election. And Professor Burden also has done some expert testimony, and we knew that if we could do this report and get it into the hands of officials, that it could make a difference for the fall election.
We all have heard for years about some of the challenges that election offices have faced with crowds, long lines. It's a difficult process under the best of circumstances. What sort of extra problems has the COVID-19 pandemic introduced that complicates that even further and maybe takes some of those problems to a whole nother level?
Yeah, so we know what causes long lines normally. It's high voter turnout and too few resources at the polls. And the too few resources are typically too few poll workers and too few check-in stations. Check-ins is usually the bottleneck, not so much the voting machines, although in some states there are like physical voting machines that you can vote electronically, and those can be a bit of a bottleneck. Okay, so we're looking at the pandemic. We're preparing for high levels of voter turnout. Now, a lot of people are voting early, so we'll talk about that in a bit. And we're looking at poll worker shortages. So again, having a shortage of a critical resource. The new addition is that people want to be safe from the pandemic, and so we have to do a lot more social distancing, which could provide constraints on the number of check-in booths and the voting booths. There's only so many you can place in some of these cramped areas where we hold elections, or at least where the voting stations are on election day. And a new wrinkle is PPE and just protective measures for the pandemic. People are wearing masks. They're asked to bring their own pen. I don't know about you, but when I'm shopping and I have to pay at the register at the end, I fumble around a little bit more than I normally would with a mask on. It just obstructs some of my view. And also I'm giving that shopper ahead of me a lot of distance in line, so it just takes a little bit longer to move through the process. And these end up being pretty big challenges for election officials. One of the things that we found was just that the PPE, it slows down that check-in, which is the bottleneck. It slows it down by just a little bit, and that could make long lines become unprecedentedly long lines. And that's something that election officials should be prepared for.
Well, as you begin to work on your models to design the kind of processes and alternatives that voting systems needed, what sort of data did you need to be able to put all this together? What was sort of the starting point of what you needed to gather to come up with these ideas?
Sure. So our model is a discrete event simulation model. The in-person voting kind of has the same procedure in various states. There might be some small differences, but the main difference is the data. So we collected some data from a couple of different places. I should say that the case study we use is from Milwaukee. So Milwaukee made national news after the spring primary. It was, Wisconsin was one of the first states to have a primary after states had stay-at-home orders associated with the pandemic. Milwaukee also experimented with consolidating their polling locations from 182 polling locations down to 5, with the idea that that would help them deal with poll worker shortages and help with social distancing. So that was kind of a new experiment to try out. And so we collected a number of data. There's some papers that have some information on what distributions might represent for check-in time, arrival time, the time to fill out a ballot, and so on. And then we looked at some Wisconsin and specifically some Milwaukee-specific numbers based on historic Wisconsin elections and the turnout, the range for turnout in the city of Milwaukee. Also, we were looking at surveys regarding who might want to vote early. In Wisconsin, we have absentee by mail voting, and anybody can request an absentee ballot without an excuse. And we also have a lot of in-person early voting. So there's 2 methods to look at early voting. And there's some early surveys indicating what people might want to do. So we were using all of that data, and then we considered a range of possible operating conditions for Milwaukee. And we also collected a little bit of information on, how many people would go to each of these 182 precincts, how they partition those into these 5 big like high school gymnasiums where they had the arenas. And then we also collected information from the Fiserv Forum, the NBA arena in Milwaukee. That's an alternative polling site on election day. And we tried to make the case study as Milwaukee specific as possible. And when in doubt, we actually watched some news footage of the spring primary to see voters going through the check-in process. And they weren't required to wear a mask at the time, but there was a lot of social distancing. People were asked to bring their own pen. I don't know if that always worked, but we were able to see exactly what happened and what the check-in process looked like to inform our new distribution of checking in with PPE usage versus kind of checking in prior to the pandemic with no PPE. We put it all together, and then we were able to analyze this case study under a variety of situations and operating conditions.
Drill it down a little bit into some of the things you discovered. You mentioned the use of a large arena for voting, but as you found that may not necessarily be the best way to go. They've done that down here in Georgia and some other places as well, that maybe consolidating voting locations is not necessarily a good idea. How did you kind of come about the data you found from that?
Sure. There's some things we looked at directly in the simulation, and then there's some observations that we have outside the simulation. First is when you're consolidating many polling locations, it offers you this benefit of being able to spread out the voting booths and maybe keep folks a little bit safer, and also to deal with poll worker shortages. The downside is that you need so many check-in booths to make that happen. So you need high levels of staff, and as a voter, it would be pretty clear that it would be maybe confusing to find the right check-in booth and to know where to go. And also, this is a new polling location that you've never been at before. So then we were just trying to think through all the additional staff that you might need to make that work. And it's not really clear that that's a good alternative if you have a poll worker shortage. It would definitely introduce some confusion. Mm-hmm. So that was the main drawback to these larger high school arenas. A second one was we were able to find this preliminary report that's a number of researchers analyzed the Milwaukee spring primary, and they found that it discouraged people from voting, right? So normally voters have, and we computed about a half a mile to their polling station, which is great. You can walk there. And the new arenas made that distance much longer for the vast majority of voters, and many of them didn't show out to vote. Mm-hmm. And so it's a way to decrease turnout, which isn't good.
Everybody likes the convenience of being able to stay close to home. One of the other suggestions you had, and this is more specific to COVID, was maybe a priority queue that would kind of separate people who may either have been exposed or tested or feel that they're somehow more compromised. Tell me how that would work.
Yeah, so we were really interested in how this new objective of keeping folks safe from, virus transmission as they voted, how that could play out. And of course, many of us probably have some area stores that have a special hour where they're only open for, shoppers that self-identify as being high risk. Well, we can't really do that in an election because we need to have the same hours for everybody. And an alternative is something like a priority queue where people that self-identify can kind of cut in the line essentially and maybe vote earlier and not wait in that long line. It doesn't reduce all of the risk. There's still the risks that they'd have inside while they cast their vote, but it definitely can reduce the amount of time they spend in line just with the same people for a long period of time. So we were curious about whether this would even make sense. And it could make sense if it didn't make the wait terribly longer for everybody else who's not a priority and just has to wait. And we found that it generally increased the wait a little bit for the low-risk voters who are waiting in the normal line, sometimes as much as about 15%, but it didn't double those waiting times. And that's because we assumed that relatively few numbers of people, I think about 1 out of every 6-ish voters would self-identify as high risk. So it's definitely a possibility to deal with that. And it's just a new avenue to keep folks safe and also help them feel that they're safe as they cast their vote. And sometimes that perception and having that option just helps people trust in the voting process a little bit more.
One of the challenges, your case study was based on Milwaukee, but voting systems are so different everywhere. The rules are different and the type of ID you need and the size of voting locales are different. How, as this varies from state to state and district to district, how complicated is it to try and create models that can be used everywhere, or do they need to be specifically targeted, as you did, to a specific location?
So our model is pretty generic. It works for most locales. It's the details are going to be different. There's a couple ways the details showed up for us. One is we didn't really drill down to the level of like where actually would we place the voting booths in these 182 locations. That was a level of detail we just couldn't get at. You also mentioned the voter ID laws. So that is something that can come into account in terms of like modeling the check-in process. And that would take time to maybe provide forms of ID. And I mentioned earlier that sometimes people fumble around with their IDs a little bit more when they have PPE on and maybe they've got gloves on. And then they have to maybe step up to some plexiglass to hand their ID to somebody and then bring it back. So those are the ways that we specifically took some of those details into account in our case study. And those can be adjusted for use in other states. But in general, I think the check-in time is going to be a few seconds slower regardless of locale. And that's probably an idea that will generalize.
Your research involved in-person voting specifically, but as you mentioned earlier, early voting and absentee ballot voting, voting by mail can kind of help alleviate the stress on that. How do all these things sort of fit together in a model that will streamline the process?
Sure, that's a great question. We didn't specifically model early voting in our model. One of the main conclusions is that we really need high levels of early voting for the in-person voting on election day to be smooth and streamlined, as you pointed out. And so we did think about what that could look like, separate from the simulation model, and that could involve having extended hours for in-person voting. Unfortunately, they're shortened in Wisconsin, which provides a challenge for election officials who might have to prepare for a higher level of in-person voting on election day as a result. But many areas are looking at making it easier to submit a ballot. So maybe a mail-in ballot by having different locations or drop boxes. Some of the professional sports arenas have offered the use of their stadiums as a drop box for your mail-in ballot, which is nice. And also some locales are looking at ways to expand early voting in person by having more locations available for doing so. And those are ideas that I really support, and they get into location analysis too. So I can definitely do the back of the envelope calculation on that pretty quickly. And all of these elements need to be strong for this upcoming election.
One of the challenges we ran into in Georgia during our primary this summer, which many people may have heard about on the national news, was how poll workers were not necessarily prepared. They had new machines in Georgia, and poll workers were trying to learn them on the fly. There were a lot of equipment problems trying to get them to work. The training and recruitment of poll workers is pretty much an ongoing challenge everywhere to get people to do this, and especially as it becomes more complicated in working the polls. How do you alleviate that? What is the best way to try to get people involved and get them trained and up to speed for whatever they may face on election day?
That's definitely a huge challenge, and a lot of places throughout the country are having new poll workers on this upcoming election day. In Wisconsin, I forget the median age of the typical poll worker, but it's above the age of 65, I believe. So these are typically voters that are at high risk for acquiring the COVID-19 virus and really suffering from maybe serious side effects of the virus. So the same poll workers we're not going to have the same poll workers on election day that we've had in the past. And these might be a very highly trained source of volunteer support for election day. So this is going to be something that will probably slow down the process. And if we slow down the service times for check-in, and that's going to lead to longer lines at the polls. So there's a number of ways to train the staff to kind of keep up with some of the new technology, as you pointed out, in some states, but also just being familiar with the procedures. And here in Wisconsin, we had the National Guard was called in for the August election that we had, and I think they will be here in the November election. So some of them may have already worked in election, and that will help on election day. And that's a source of at least having extra workers to account for the fact that the poll workers on election day might not be as efficient as they've been in the past. It's all the more reason to have extra poll workers on hand.
And as we speak today, we're just a few weeks away from election day. Early balloting has started in some places. People are mailing in their ballots. Is there still time to implement changes and refine the process this close to election day? And are officials very much open to these kind of ideas?
Oh, absolutely. Planning in election takes election officials months on a good year, right? So this is definitely something that they've been doing. They're still fine-tuning their approach. There's a few things that election officials can do. One is that they can continue to recruit poll workers, to have extra poll workers for each polling location. So our analysis recommends roughly about one extra check-in booth per location to make things run smoothly. That's something that they can do right now. They're still recruiting. The second is looking at, early voting and understanding that the importance of early voting. This is something that they can promote. They can have videos to tell people how to do it, how to register early, or where to go for in-person early voting. That will really alleviate the risk of long lines on election day. So there's quite a bit that they can do right now. And governors can even decide to call in the National Guard to deal with poll shortages if they need to. So that can be like a last-minute save from a government official. The key is they have to understand how important that is to have enough poll workers on election day.
And of course, as an industrial engineer, the key is continuous improvement. So once this election is held and we see what went right, what went wrong in various areas, what can we take from this to learn and make the process better going forward?
I love the idea of continuous improvement. Agreed.
Are there any particular things that we should be looking at from this election that may apply to elections in the future, though?
Well, there's a couple of things. One is there are tools out there that use basic industrial engineering methods, such as queuing models, to estimate how many check-in booths and voting machines polling stations might use. And these are widely used throughout the country by election officials to plan for elections. But all of that was designed with data not involved with the pandemic. And many of the performance measures they look at, which are, IE related goals like waiting times and line lengths, those are really focused on just kind of typical operational performance. But as IEs, we can focus on, what are the new criteria for elections based on, public health, and how do we incorporate those in? How should we maybe alter these tools so that they give better estimates for voting booths and poll workers that might be more robust across a variety of scenarios. There's a lot that we can do in terms of continuous improvement and just supporting officials by giving them the best information. If they have better information, they can do better planning.
And of course, we all hope this will be the last time we have a pandemic involved when there's an election too. So that will certainly make things easier right there, no doubt.
That will make things easier, but I bet in the future, election officials are going to be concerned about just keeping people healthy while they wait in line.
Sure. Yeah. The lessons I'll learn. Just as a little side sort of personal thing, you spent some time in Germany earlier this year. You were on a Fulbright Award, and you've been looking to expand the profession internationally. Your blog, Punk Rock Operations Research, is at punkrockor.com. Just tell us a little bit about some of your work there.
Oh, yeah. And unfortunately, I had to come back early from Germany, but it was a really wonderful experience. I went out there with my kids, and I was planning to work on some new research related to public sector operations research and my area of emergency medical services. So I'm still nurturing those collaborations, but it was a great experience just to kind of talk about my research internationally, especially in public sector systems. They operate very differently in different countries, and I was really excited to start looking at those issues. And there's some commonalities that we have, like good principles that work across countries, but then there are other interesting research topics that can emerge from that. It was really great to be on the Fulbright. I speak German. I'd like to say that I'm fluent, but I'm not quite fluent. And it was nice to be there for a little bit and even give some talks internationally. So hopefully travel will return at some point. Right now, I'm just giving virtual international talks. And
we certainly celebrate our international members. We actually have a special issue in our November IISE magazine on our international issue featuring several stories and chapters around the world. So we look forward to that. Professor, thank you so much for your time and expertise. Congratulations again on your fellow award. We look forward to seeing you virtually at the annual conference and receiving that award. And thank you for sharing your expertise. It's a very timely topic, and we look forward to learning more about it as we go ahead.
Thanks for having me.
Our guest now is Gretchen Macht. She's an assistant professor of mechanical, industrial, and systems engineering at the University of Rhode Island. Her research interests include human factors, alternative energy, human systems engineering, team performance, sustainability, electric vehicles, and solar energy systems. She's currently director of the URI Voter Operations and Election System Project, known as URI Votes, which has been awarded several grants totaling $700,000 to conduct research and recommend steps to help several polling locations across multiple states execute successful in-person voting. She's also an IISE member. Professor, thank you for joining us today.
Thank you, Keith.
As we get started, tell us a little about your background and why you settled on some of the research areas that you specialize in.
Sure. So I got started in industrial and systems engineering through meeting Miss Joshi at Penn State, who asked me what I like about a stapler. And I was like, well, it's got to work, right? And it's got to feel good, and it's got to be able to be stapled just right. And what's the point of using it if it doesn't work? And I went through this whole list. And after changing my majors 4 times, my 5th time was my last one. And I was convinced, and I haven't moved from IISE since. And ever since that, in terms of my educational career, it's been based on support from individuals who basically have been asking me, you can do more with that idea. And growing up and watching my dad as an instructor at a local community college, it's just been kind of this trajectory that I think that if I weave all of that together, that my trajectory was always here. In 2015, I joined URI. And then in the spring of 2017, I got a call from the dean of the College of Engineering that asked me to talk to the Rhode Island Secretary of State. And I said, okay, what could she use my help with? And we had a conversation about voting systems. We had a conversation about facilities layout planning. We had a conversation about simulations and discrete events. And it was really fascinating because the secretary told me a story of when she took a class when she was a graduate student in Columbia, and she knew that this stuff existed, but she ended up dropping the class and didn't know how to execute the problems, but she knew that there were people to do the job. And that's why somehow through the universe, it got to me. And I've been working on it since the fall of 2017.
Just tell us a little bit about how URI Votes works, what your goal is, and what sort of outreach you're having to try and influence and help the voting processes.
So the goal of the URI Votes project is to help ensure that no one has to wait in line to vote. We understand that in most elections, there are a few locations where that is an issue. We understand that we are in an unprecedented year, and we understand that people are going to have to wait in line, but we want to understand what that looks like, and we want to make it as best of a situation as possible. So the outreach, we are working with various communities across the country to help make the system as balanced for flow with respect to resources, as well as considering public health and safety to make it as mitigated as possible for in-person voting.
And voting's already been, in some areas, a bit of a challenge because of long lines and high turnouts, particularly in a presidential election year where turnout is always so much more. And now you have the whole COVID-19 factor built into that as well. What sort of extra challenges has that laid on a system that is already a bit stressed?
It's another constraint, honestly, that we are trying to understand, that we are trying to add into the simulations. We need to consider social distancing to ensure the voter safety and looking at it in terms of federal, state, and local guidelines. We also need to consider the fact that there are a lot of poll workers who are not enthusiastic about participating and in-person voting. There are a lot of them that are and then have volunteered all across the country. But in terms of overall turnout, it is much lower. It is much harder. And to take a location and to make it abide by the COVID guidelines, both federal, state, and local, has been a challenge. And it is putting additional constraints on the system. And we are trying to work with those to help understand them better. So if we have to look at what that looks like for COVID, that really compounds the system. So if we have this lack of available poll workers and social distancing guidelines, the voting systems, although resilient, are not necessarily agile enough for swift changes. So we need to work with election officials to help them do their best in establishing the system for both layout and flow, and to execute it so that everybody can vote however they choose to vote.
And do you also have to factor in to some extent what the case load of COVID is in a particular area? And is that something election offices are factoring in as well as to just how bad it is in a particular place?
So in terms of the level of COVID, we do not include that in our models. Those are things that the election officials are very aware of. What we are trying to do is see if the flow of the system with their requirements works. Mm-hmm. And the reason for that is that technically in the United States, you can go to the polls in whatever condition, and as long as you're registered to vote appropriately in your jurisdiction, you have the right to vote. So what we're trying to do is look at how long people are in the system, how fast can we get them through the system, but it does change the overall dynamic. So originally the voting problem is I have this square footage, I'm going to fit as much of it in there as possible, and I'm going to get as many people as through as possible. And it doesn't matter if these voting booths never get used, but I'm just going to put them all in there. Mm-hmm. And that has served us well enough, but it has not in certain areas in the last 20 years. So when we start talking about putting those constraints, now we can't just put as many in there as we want. We have to stop and consider the impact, the balance. We also need to start looking at the workers themselves and their own utilization. And if you have a solely dedicated sanitization worker, so this is a poll worker who goes through the system and cleans every time somebody uses a particular part of the system. So a voting booth or an optical scanner or a ballot marking device, and they have to go and clean that. How often are they cleaning? What is their particular rate of exposure? So we are looking at that as well and looking at helping election officials schedule those types of resources if and can that it is a problem. So that's really complicated for if it's a problem, we're helping them try to fix it. But it is quite the math problem.
Yeah, it's a moving target because the case numbers change in a particular area so quickly too. So
yeah, and it's because the situation is ever evolving. It is an issue, and the systems are not designed to be flexible or agile enough to switch on a dime. Mm-hmm. And then if there is a high propensity of COVID in a particular location and a particular election official has contracted that shuts down the entire system. So it is a system that they are working on and that they are aware of the vulnerabilities and they're working through it. It is just an interesting place to do research. In your introduction, Keith, you were talking about solar and electric vehicles and teams, and all of that stems from my background in the solar decathlon and being interested in this larger team dynamic and how we can get sustainability through teaming and that type of research. And then this research fell in my lap, and so thankful for a well-rounded industrial systems engineering education and toolkit so that we can go into any domain and help as best as we can. So that's where we're trying to take that information and process it and help the election administrators make the best decisions possible.
Yeah, it's definitely an IISE problem that needs solution.
Yes.
Your models, from what I read, you applied data from 3 different areas of the country, Rhode Island, Michigan, and Los Angeles. You got an East, a Midwest, and a West. And as we all know, the voting processes in the United States vary so much, not only from state to state, sometimes from county to county, precinct to precinct even. And you had mentioned that you don't want a one-size-fits-all approach. You want to be able to tailor it. How do you take all the different data, the different types of voting? You got different sizes of venues and locations. How do you factor all that in to come up with a solution? It must be an enormous amount of data you need to be able to create that.
Indeed, it is a lot of data. I mean, if we look across the U.S., there are roughly 3,100 counties. If we look at the number of jurisdictions, in which we can define as areas in which people vote or have control over how people vote in terms of making those decisions, opening locations, making that available, either in person or vote by mail. We have over 10,000 jurisdictions. So when we start talking about executing democracy in a federalist system, there are multiple variations. And there are the freedoms for people to do what they want in their system. So when we have that type of variability, everything is highly local. So we are trying to work with every location to specify the models based on their data and get the best verified models that we can then validate to understand what happens in that particular location. So yes, we have worked with the state of Rhode Island, Michigan, and Los Angeles, and they are different locations that have fundamentally different systems. But there are a lot more systems that are different out there. And when we move to a different community, that's one of the first things that we ask. So tell us a little bit about your process. Tell us about your system. Do you have a tear off station? So for some locations, there's a ballot where they tear off the top or the bottom, and then that tear off then gets stored somewhere for risk limiting audit purposes. Or there's other opportunities where you have different optical scanners. So this is where you take your ballot and it gets scanned. And those different scanners have different rates, have different timing. Different communities have different ways of processing that information depending on the size of the ballot, as well as the length of the ballot. So there's a lot there. There's a lot of data. We have been very fortunate that the election administrators trust us with that. And we have been using that in our models that we have created for those communities. So not every community needs to use our model, but when we have communities that have very particular challenges where these constraints are across thousands of precincts or hundreds of precincts, then we're able to help them where a generalizable model is not going to be specific or tailored enough to their needs. And then when we start talking about the differences between vote centers and polling locations in terms of where this is your assigned, this is your precinct, you show up, you vote at that location, no matter what the election is, or you have a vote center where anyone can go to a particular location as long as it's open. So the math for them are different. The models for them are similar yet different in terms of how people arrive. So the arrival patterns in terms of voting systems has been traditionally quite evasive in terms of what we're able to understand. But the fascinating part about all of this is in the last 20 years, technology has been placed within our voting locations like never before. It's ubiquitous. The data is there. It's how we choose to access that data, use that data in our models, and able to execute for a more holistic outcome.
You mentioned the different types of venues and locations. We've got several areas now that are opening up large arenas here in Atlanta. The basketball arena has been opened up as opposed to going to the library or the local school. Does that help having a larger venue like that? Does it complicate things? What are you finding so far on whether that is a plus or a minus in speeding up the process?
Well, size of location is definitely a challenge. You have some locations that are cozy, right? Where you have the local city hall that, can fit maybe one or two voting booths based on social distancing, but it can still process voters. When you have a larger venue, it still presents its complications and can still process voters, but we have to be more concerned about the overall setup and how that works is a whole system because the system is larger. So we can have issues that perpetuate in a much larger system. So we have to be cognizant of what that means. Both of them are messy. They're just different types of messy.
And you mentioned the need. It's a whole separate process of having to sanitize surfaces now and machines and scanners. Having a larger venue may just complicate that as well. I mean, you have to set up almost a whole set of processes just to be able to do that, right?
Yes,
yeah,
we do. What we have to do is help the local election officials help solve that problem. We are working with the community of the Stanford MIT Healthy Elections Project, which has a lot of information out there to help make those things as safe as possible. Mm-hmm. And have those recommendations. And then we are releasing our own setup manual for both general locations as well as those super centers or extra large locations that are trying to fit hundreds of resources in a particular location. So we are trying to work with all different levels in terms of the sizes of the locations, but they do present their own particular challenges. But at the fundamental core of the IISE problem, it is the same. It is that we have to look at layout in this process as a constraint. And traditionally, the voting system has not. You talk to election administrators and they assign numbers. And when they can't be used, then they need to understand why. So yeah, Atlanta had some particular challenges in the presidential preference primary for that reason. Mm-hmm. So they sent what they thought was needed and then they couldn't put it all in there. So that presents challenges everywhere. Another
challenge and major challenge that we had here, and I'm sure other places, is just being able to recruit and train poll workers properly. You mentioned that as well, that there may be poll workers that are hesitant to take part because of the health concerns. What do election offices need to be able to get these folks up to speed and trained? You got different machinery, you got different processes now. You've got people who are not professionals, they're volunteers and they're doing this for the day. How do you go about the process of getting them ready to go through this very difficult procedure?
Yeah, so that is out of the scope of our research. But what I can tell you is that there are communities of researchers and individuals out there that are have prepared materials to help these different types of communities. If you look at the Center for Technology and Civic Life, if you look at some of the work that is being done throughout the country, those materials exist and they are helpful. You have different webinars that have been going on for those types of things throughout the entire year. You have a community of election researchers and different foundations who are working with everyone to try and get that done. The challenge is based on the math. So if depending on what resource you look at, you can have anywhere upwards of 20 to 25% of previous poll workers in terms of the population were 70 plus. Which now, if we look at the at-risk demographic associated with the pandemic, that is definitely them. So when we start looking at just the volunteer of poll workers, there are a lot of different opportunities for individuals out there. I know in the state of Rhode Island, as long as you've registered to vote and you are 16 or older, you can actually work as a poll worker. Even though you cannot vote yet, you can still sit there and work with your local jurisdiction to help in-person voting. So there are different opportunities. I think that if you are interested in becoming a poll worker, that you should check out those opportunities and go out there and make a difference. And if you have served, but you can't serve now, thank you very much. Stay safe. And I think that that's where we are right now. And we have to start considering the whole of the situation and have everybody recognize that and come together as we always have as Americans.
Where do you stand on the project now? We're just, as we speak, a few weeks from Election Day. Is there still time to be able to implement some of these, or are a lot of your plans and recommendations going to be for after the fact? How are election officials being able to take this data and this information and use it now?
That's an excellent question. We've been working with various communities for years, and some of them just a few months ago where we got started. Mm-hmm. And ultimately, we are still running models and we are still helping with these challenges. And I think the reason for that is, although when election officials have to make plans and decisions, those timelines are not new. They are either based on statute or they have been based on experience, but they have made decisions months ago or weeks ago. But now any sort of fundamental change in the system can make the system either more resilient or vulnerable. So what we are trying to do is help make sure when they make those decisions that they can help see what direction that is going in. So, voter behavior has always been elusive, but election officials are doing their best. You're right that over 2 million plus individuals have already voted, and this is the beginning of October. But ultimately, we are still doing our best to assist officials in these evolving landscapes, because they realize that when they made those decisions might not be the reality of what is coming or what is here.
So as we go through this election day, there'll be a whole new set of data based on what happens, based on either what changes are made or what problems. What kind of information are you looking for that can help for elections down the road? Obviously, as this is going to be an ongoing project as you continue continuous improvement, which is what IISEs do. What kind of things are you going to be looking for that will kind of help for down the road?
So that's an excellent question. And yes, continuous improvement, that is what we are built on. So looking at the data and seeing where that can project us into the future. And honestly, we don't know if this is the first election associated with a pandemic or the last. We have no idea. And that is a scary and unknown idea. But if we can use this information to help process future election day efforts, that would be great. The challenge is to synthesize this new knowledge so that we can develop a better understanding. And what that means is, in every location, there is technology, and in that technology, there is data. And how can we use that big data to help us understand more about arrival patterns, to help us understand more about geographic differences in arrival patterns? If you have locations where people work, but they don't live, but they vote where they live, not where they work, what does that look like? And ultimately, this is an opportunity to better understand that data with that increase in technology in our voting system so that we can make better decisions in the future. And I can't say anything about simulation without talking about having a validated model. So first and foremost, we need to understand what is happening on the day of elections, understand what that data looks like, collect some of our own data, and then put that into our models, our verified models that have been looked at by election administrators and various stakeholders, and validate those models. So we have to do the good work first, and then we can take that and then tweak it, edit it, use the available data to expand it, to help understand what that behavior looks like. The value of having an industrial and systems engineering background is that we can combine topics like voting behavior, with stochastic processes, with uncertainties and unknowns. And the math is messy, but it's fascinating. And those are the types of things that we can use to help process future improvement. Additional things that we can look at is help election administrators with the understanding of total quality management, the Toyota production system, helping them understand that when we make decisions, how can we see the ripple effects a few steps from that decision, much further down in terms of a longitudinal timeline. We can help understand this model that traditionally looks at it that every election is different. And since every election is different, we can't possibly use the data from the previous election to help us understand the next election. And we understand as systems thinkers that that's not necessarily true. It's not that all data can't be transferred, but that what data we choose to use, what can be transferred, what part of the system is now considered stale, but what part of the system is also considered the same. And when we start looking at the election system and all the processes inside of that for voting, we have temporary systems. We do these types of things with national disasters all the time, where we have to set up a system, have it temporarily run, and then when the system is done serving its function and or purpose, then we take it and we remove it and we go on to the next thing. So there are a lot of tools and skill sets that industrial and systems engineers have that can help solve the voting systems domain. And it's a challenge because we also need to help everyone get there together. So it's some fun, messy math.
It is.
But at the same time, it's worth doing. Our supporting our democracy is worth it.
Well, we can certainly feel your enthusiasm for the project coming through.
Thank you.
Because we all want a glitch-free voting system as much as possible and look forward to hopefully an election that comes off without too many problems. And Gretchen, we thank you for your time. We look forward to seeing how your work is going to be applied now and in the future. And we look forward to talking to you again about how it all went down the road. Good luck.
Awesome. Thank you very much, Keith. I really appreciate it.
Thanks for listening to this episode of Problem Solved, the IISE podcast, a production of the Institute of Industrial and Systems Engineers in Metro Atlanta. This podcast is produced by David Brandt, Keith Albertson, and Michael Hughes, and edited by David Brandt. You can listen to all episodes of Problem Solved and learn about sponsorship opportunities by visiting our website, podcast.iise.org. You can also learn more about IISE at the Institute's website, www.iise.org.